Hello Math 45 students, we are going to continue learning about Chapter 2. So in this section, 2.2, we'll be talking about linear equations in one variable. So with these type of equations, three things can happen. You can either have a conditional statement, meaning that you get one exact answer, or you get an identity, meaning that you have infinite many solutions, or you have an inconsistent answer, which means that there's no solution. So for example, for your inconsistent, if you get something where two different values are equal to each other, well, that can never happen. You can never be in debt $15 and still have $20. So that is no solution. Okay. All right. So for part A, we're going to go ahead and solve these problems. So when I look at this, it says, hey, solve the following equations. So it looks like I have distribution. So I'm going to go ahead and on the right-hand side, I'm going to write out what I'm going to be doing. So here are my steps. So the first step, I see parentheses and multiplication. So that tells me that I'm going to distribute. So that's going to be my step number 1. So I'm going to go ahead and do that with my distribution. So I have the 4 that's going to get multiplied in, and I also have this negative 5 that's going to get multiplied in as well. So this is going to give me my 4x minus 12 plus 12 is equal to my 15. Now when I distribute, it would be a negative 5x and a negative 30 that I have, okay? So now I want to think about my step number 2. What am I going to do? Well, for step number 2, what I'm going to do is I'm going to combine like terms. That means things that have the same ending are going to go ahead and combine together. So let's see what we actually have. Well, it looks like I have this negative 12 and that positive 12. Well, when I combine them together, what ends up happening is they cancel out. So I'm just left with the 4x here. Now, on the opposite side, I still have that negative 5x, but now I see I have a positive 15 and a negative 30. So those two are going to combine together. So a positive 15 and a negative 30 is going to give me a negative 15. Okay. So now I want to think about the next step that I am going to be calculating. So instead of after combining like terms, my third step is going to be isolate the variable. That means I want to get the x all by itself so that is just going to be x equals some number if possible. So the way I'm going to do that is since this is a negative 5x, I do the opposite to move it across the equal sign. So it would be a positive 5x on both sides that I will be adding. So that is going to give me a 9x is equal to a negative 15. The x is still not isolated. It's being multiplied by 9. So what's the opposite of multiplication? Division. So divide by 9. Divide by 9. So that this side it cancels, and I'm left with x is equal to a negative 15 divided by 9. Now, there are going to be 2 more steps here. So after I have isolated the variable, in which I have done, you always want to simplify if possible. And then that last step, if possible, you want to classify equation. So I want to make sure that I simplify my answer. So a 15 and a 9, well, they have a 3 in common. So I'm going to divide by numerator and denominator by 3. So I'm going to get that x is equal to a negative 5 thirds. And that will be my final answers. So since I actually have x equals a number, then I'm going to say out of the 3 things that I can choose, So I can choose conditional, I can choose identity, and I can choose inconsistent. Well, the best fit here would be conditional. That is what my answer is going to be. So let's try to do this again for part B. So for part B, again, it might be helpful to write out my steps, and these steps are going to be slightly different only because I'm dealing with a fraction. So over here, I'm going to have my steps. Give me 1 second. So steps for this fraction, what I want to do is I want to make sure that I find my LCD. So I need to find the least common denominator. So when I'm looking at this, I have a 2x and a 3x and a 3. So my LCD here is going to be a 6x. So now that I found my LCD, the way I'm going to continue this is I'm going to make sure that I get rid of the fraction by multiplying everything by the LCD. And the reason you do that is so that you can get rid of the fraction. So let's go ahead and try to do that together here, okay? So I know that I'm multiplying each term by my 6x. So I have my 7 over 2x, and I'm multiplying by the LCD. I said the LCD was 6x, and you can write it over 1 if you like. And I have minus my 5 over my 3x. So that's a different term, so I'm going to multiply that by my 6x over 1. And it's equal to my 22 over 3, so I'm multiplying that by my 6x over 1. So when I do that, let's see what happens. Some things are going to be able to cancel out. Well, 2 goes into 6 3 times, and the x cancels. So you're left with 7 times 3. Subtract, and over here, let's say 3 goes into 6 twice, and the x cancel. So you have 5 that's being multiplied by 2. And over here, you are going to have that 3 goes into 6 twice, and you still have the x there. So you're going to have 22, and this is going to be multiplied by my 2x. So now let's go ahead and combine like terms. So I'm going to go over here to step number 3. And it's going to combine like terms. So when I combine these like terms, I'm going to have 7 times 3, which is my 21, minus 5 times 2, which is 10, and 22 times 2x, which is going to be my 44x. And again, combining like terms, 21 and 10 are like terms, so 21 minus 10 gives me 11, and that's equal to my 44x, okay? And so now for my step 4, I definitely want to get my variable isolated. And once I get that isolated, then of course I want to simplify if possible. And the last thing I'm going to do is classify the equation. Okay, so I have all of my steps listed out to kind of help me out. So again, to isolate the variable, it's being multiplied by 44. So the opposite of multiplication is division. So I'm going to multiply both sides by 44. So this is going to give me 11 over 44, which is equal to my x. But I can certainly divide. I am going to divide by 11 on each side. So then if I had x is equal to 11 over 44, when I simplify it, that would give me 1 over 4, since I am dividing top and bottom by 11. So my final answer is x is equal to 1/4, which tells me that this is also conditional. Okay. So I'm going to go ahead and do part C now. So I'm not going to write out the steps. The steps are written very clearly. I even typed them out for part A and part B. So for part C, I'm just going to go ahead and dig in here. So, okay, I have this 8, so I'm going to distribute. I have this 20, I'm also going to distribute. This 5 will also be distributed. So the first step is to distribute whenever I can. So this is going to give me a 16m minus 32 plus 20m minus 100 is equal to my 4m plus 25m minus 100 minus 32 plus my 7m. So what might be helpful is to rearrange it so all of your m's are together and all of your numbers are together. This isn't necessary, but I think it's just kind of helpful. So I have everything that's going to be an m on one side. So I have my 16m plus my 20m. And I still have minus 32 and minus 100. And again, I'm going to do the exact same thing over here. So I'm going to get all of my m terms together. So I have 4m plus 25m plus 7m. And I still have minus 100 minus 32. So combining like terms, I have 16m plus my 20m. That's going to give me 36m. I also have negative 32 and negative 100, which give me a negative 132. Now I have 4m plus 25m plus 7m, so when I combine all of those together, that gives me a 36m. And again, I have negative 100 and negative 32, which is a negative 132. So now at this point, you can see that the left-hand side of the equation is the exact same as the right-hand side. So I can stop here, or if you don't see it yet, you can keep going. You can add 132. And what happens is that it cancels out on both sides. So I have my 36m is equal to my 36m. And again, if you see it here, you can stop. If not, you can keep going. So you can subtract 36m on both sides. And you get that 0 is equal to 0. So hopefully now you can truly see what's happening. So when you have 0 is equal to 0, what that tells me is that you have an infinite amount of solutions. So since you have an infinite amount of solutions, this is an identity. So that is your classification. Your classification is going to be identity. Okay? So now for part D, it's exactly the same, except now you have decimals, which you have your calculator if you're not really familiar with decimals. So again, what I like to do is I like to combine like terms. And I'm going to reorder them so it makes sense to me. So I have my 2.5y minus my 1.2y. And I have a negative 3.4. That's going to be equal to, and it looks like I'll only have one y over here, so that's a 1.3y. And I have my plus 6.7 and my negative 9.1. So if I'm adding those y's together, I have a 1.3y and a negative 3.4. And I still have my 1.3y. And over here, 6.7 7 minus 9.1, that is going to give me a negative 2.4. So now what I'm going to do is I'm going to subtract my 1.3y from both sides. When I end up doing that, it cancels out. So you're left with a negative 3.4 is equal to a negative 2.4. Can it be possible that two numbers that are different be exactly the same? No. So in this case, you're going to say no solution, which tells us that the classification is going to be inconsistent. It does not work out, it doesn't make any sense, so we are going to say inconsistent. Now, for the slope of a line. So hopefully you guys remember the whole y equals mx plus b. So that m represents your slope, okay? So the slope, there is a formula. As long as you have two ordered pairs, it's going to be the difference of y's being divided by the difference of x's. And maybe some of you guys have remembered m as your rise over your run. And really, that definition, we say that until we are graphing, but it's the same idea, right? We want to just make sure that we know the algebra first before we can graph it.